let's figure out how we're going to deal with time. First, let's just look at how we can display the time in the year using an actual date time object. And then let's talk about why that's not nearly enough to get our job done. In the New Year's countdown screen here, which is above the landscape, it contains the landscape. Let's define a date format, which allows us to go from a date time to a string. This requires the internationalization package, by the way. Here in PubSpec, the Intel internationalization package, this is what knows how to interpret date times for different string representations. Go ahead and add that to your PubSpec, pull in your dependency. At that point, you will be able to say date format, and we'll just call it time format in our case. And we're going to define a string that represents how we want our date and time to be displayed. And this is literally for our time. The year we can just access directly. I'll show you that in a moment. But our time, we want to show the hours, the minutes, the seconds, and then AM or PM. Little h goes from 0 or 1 to 12. Big H goes from 1 to 24. Or is it 0 to 23? I don't know. I never use military time. But the point is, I want a traditional time display, AM and PM. So we're going to go, you can say 1 to 12, or it's kind of like around the clock, 12 to 11, whatever. You know what I'm talking about. The digits 1 through 12 will appear in that position. And then what we can do is we can, let's say that we want to take the time right now. We can pass in a string, which is time format dot format now. And we can also pass in a string, which is now dot year. Let's save. You'll see over here, it's kind of hard to read. Maybe it'd be easier to read if we were in, I don't know, afternoon mode. That one's still a little difficult. How about evening? A little more contrast there. Clearly, we're still in 2020 when I'm making this, and apparently it's about 9:30 p.m. my time right now. We can display a specific time, and that's a good start, but we have a lot more to go. First, we want this time to change every second. We want it always updating. We need something significantly more than what we have to accomplish that. Problem 2. As we're sitting here working on this, there's no way we can finish this project if we're stuck with only the current time. We need to test, again, morning, afternoon, evening, night. And more importantly, we need to test the New Year's countdown. Like, imagine if you had to wait for the actual New Year's countdown to see what happens to your app during the New Year's countdown. That's crazy. We need to be able to provide a fake time, and we need to even based on the fake time, we need time to continue moving forward, even based on our fake time. Essentially, what we need to be able to do is we need to tell our UI, pretend that it's 11:59 p.m., 49 seconds, go. And then we expect to see the countdown, right? Not only is this necessary for us developing this, we need to write tests for this too. If you're creating a special effect for New Year's, you better have some tests that make sure it does what it's supposed to do all 10 seconds leading up to New Year's, right? This means we need special control over time. And this is a recurring theme in app development. A lot of things that we do are actually based on time. And if you can't fake that time, you have an untestable solution. And it's very dangerous. Let's figure out what we're going to do here. In this particular case, I'm going to suggest that we implement a stateful widget called time lapse. And this thing is going to be in control of dealing with all those details that I just mentioned. But we do need to forward some information to it, because here's one thing that I want to be able to do. Up here, where I have my New Year's countdown screen, I want to be able to control what time it thinks it is from right here. I don't want to go repeat myself multiple places. I want to pass it into the top and have everything just work the way I expect. So I want two pieces of control here. I want the override start date time. So I can say something like datetime.parse 2020 12/31, that's December 31st, 2020, 23:59:49. This represents the date and time 1 second before the countdown starts. I want to be able to pass that date time in and get the UI that I expect. We haven't implemented that yet, but I want it. So I'm putting what I want here, and then I'll figure out how to make it work. The second parameter I want is do tick. What I mean by this is, should time start moving forward, or should we freeze at a moment in time? I want to control both, because when I'm fine-tuning the UI, I don't want time moving forward, because then I'm fine-tuning a UI that's animating out from under me. That's too difficult. I want to freeze a moment in time, get the UI just right, and then check it out with time moving forward. I want control over both of these things. Because I want to pass them into this widget, I need to accept them as widget parameters. So we need a final date time override start date time and final Boolean do tick. We'll create the constructor that takes in both of those. And I don't care about that being const. Okay. Now with those parameters coming in, what do we do with them? I mentioned that we want this time lapse thing. I actually want those exact same parameters on time lapse. Okay. So I'm going to copy them. Going to bring them down here into time lapse. Going to generate the constructor. And again, the reason, even though I'm using them here in time lapse, the reason that I'm taking them into New Year's countdown screen is because I want to be able to orchestrate everything from here. If we didn't expose these parameters at the very top of our widget tree, then when we go to test this widget, we wouldn't have any control over time. So we take these parameters in at the top level of our tree, and then we forward them. Here above landscape, we will introduce a time lapse, and we will forward the override time and the do tick. Okay. So yes, time lapse is the one that's going to process those configurations, but we get to pass it in at the very top, which allows us to control these things within our test. And that's important. Now, for the moment, we're going to introduce a child property here, but we're going to come back and replace this later, and you'll see why when we get there. But for now, we can take a child in. So now we have time lapse surrounding our landscape. We can save. We probably need a hot restart because I've brought in stateful widgets. Let's see, where am I looking for this? Right here, hot restart. Oh, I'm sorry. What we actually need is to return the child that we're given. And there we're back to where we were. So time lapse is essentially a do nothing widget right now. But what we want to do here in time lapse is we want to go ahead and implement this control over time. Within the time lapse widget, we need, so if we were only using the real clock, then we would only need one time. That's the current time. And every time the current time changes, the current time would change. But what we want to facilitate here is the ability to pass in a fake time, like 11 seconds before New Year's. And we want that time to be able to change. This leads us to the introduction of two variables. We want the initial time. That's the time that's given to us. And then we want the current time, which is the initial time plus some additional time. But this now begs the question, how are we going to watch time? When I say time changes, what does that mean from a Flutter perspective? What it means is that we need a ticker. A ticker is how we get callbacks from Flutter as time moves into the future. So we'll import ticker, and then we will mix in single ticker provider state mixin. This gives us the ability to create a ticker so that we can watch the passage of time. Now let's figure out some of the lifecycle stuff that we need in our stateful widget to make this happen. First, let's deal with init state. Init state runs when this widget is first created. We may or may not be given an override time. If we're not given an override, then we want to use the normal wall clock, the normal time, the real time. But if we are given an override, we want to use the override. Therefore, we will say if override start date time is not null, then our initial time is equal to the override time. But if we're not given an override, then the initial time is equal to the current time. We will also initialize current time to equal initial time because no time has passed yet. The current time is equal to the initial time. Also, if do tick is true, we want to immediately start ticking. And actually, let me change that. We could go two ways on this. We can start and stop. I take it back. Yes, where I was going is probably what we should do. If do tick is true, we will start our timer. But if do tick is not true, we will not start our timer. Our ticker, ticker. But one problem here is we haven't instantiated the ticker yet. So ticker equals create ticker. And we're going to pass in a callback. We will call it onTick. Now you might be wondering where this method create ticker came from. It came from our mixin. That's what allows us to create the ticker. And then if we want to start watching time, we start the ticker. But we need the callback, of course. We need to invoke something as time changes. For now, this will be a to-do. We've now handled the initialization of the widget, but it's also possible that the widget changes over time, that the parameters of the widget are altered over time, which means we also need to implement did update widget. So what are the conditions that we're interested in here? Well, if nothing has changed in the widget, then we don't have any work to do. But if anything has changed in the widget, we need to update some of our internal variables and configuration. So if widget override start date time is not equal to the old widget dot override start date time, this means that either, one of three things may have happened here. Either there was no override and now there is, or there was an override and now there isn't, or there was an override with a particular date and now there's an override with a different date. One of those three things has happened, and we need to make sure we deal with all three appropriately. If widget override start time, so if we do not want to override anymore, so we were overriding and now we don't want to override, we want the real time. Then what we're going to do is we're going to set initial time to now. We want the real time. Otherwise, we want initial time equal to the override time. Those are the two options, right? Either we're using the real time or we're using the override time. Now, after we make that change, we need to kind of reset our ticker so that we start watching the passage of time correctly again. So we're going to set, first we're going to set our current time back to initial time because we're kind of resetting things. So now the current time is the initial time. And if widget do tick is true, so if we want to tick forward, we're going to take the ticker, we're going to stop it in case it was already running, and then we're going to start it. Again, based on what we want in terms of the override, we either want to use the real time or we want to use whatever requested override time was given. Because we're resetting things, the current time is set back to the initial time, which is, remember what we had up here. We're just going through a similar process. And then, if the widget wants us to watch the clock over time, we stop the ticker in case it was already running, and then we start it. Whether it was running or not, we're definitely starting it now. Now, there's one other category of change that may have happened. Let's say the override time didn't change, but the do tick changed. If we now want to tick, then we start the ticker. If we don't want to tick, then we stop the ticker. And so hopefully this is clear, right? If previously we were frozen and then we want to start moving through time, we start. If we were moving through time but we want to freeze it, we stop. But I think this here, what we were doing in the other situation is not quite complete, because it's possible that the override changed and the do tick changed at exactly the same time. To get this right, I think what we want is ticker.stop right here. So no matter what, we stop, but we start again if the widget wants us to do tick. I think this is the correct thing to do. So now we've handled all the intricacies of changing the widget configuration. In terms of life cycle, the last thing we need to deal with is disposing of these things, which in this case is just the ticker. We need to dispose the ticker so that we don't have any memory leaks after this widget disappears. Now, every time that the clock ticks, what do we want to do? This elapsed time, by the way, is a duration. And you might think that elapsed time is the amount of time that went by since the previous tick. That's not true. Elapsed time is the total time that has passed since we started our ticker, which means elapsed time is all the time that's gone by since initial time. Okay, so with that in mind, if initial time is null, which it should never be, but just in case, we will set it to the current time. And now we want a new time, which is initial time, and we're going to add to it. The new current time is the initial time plus however much time has passed, right? That's the definition of elapsed time. Now, on the screen, we are only displaying down to the seconds, hours, minutes, seconds. If only 50 milliseconds have gone by, there is no point in us repainting the screen. The only reason we have to repaint the screen is that the number of seconds have changed. Only if new time dot second is not equal to current time dot second, we are going to set state and update the current time to the new time. This only has an impact. We only need to do this if we've gone from like 49 seconds to 50 seconds to 51 seconds. This is actually all the time management that we need, but what we now find visually is that we are always returning the child exactly as it is. So let me save this. We'll even do a hot restart, and you'll notice that despite all of this stuff, nothing new is happening here. We show a year and a time, but it's still static. It remains exactly the same. Why is that? It's because what we are displaying is this. We're still basing our display on the current time and only the current time at the very first moment that we build our widget tree. How can we allow our landscape widget to configure itself for the current time when time lapse is the widget that's determining the current time? This is a canonical case for a builder, a function that we can pass to time lapse, which will create the child on demand. So here's what we do. We don't want a child at all. What we want is a date time builder. You can call it whatever you want. I'm calling it a date time builder. Any function that produces a widget in Flutter is typically referred to as a builder, and this builder is going to receive a date time as a parameter. So check this out. We're going to take in a function that returns a widget. Can't remember if it's capitalized or not. Actually, it might just be, I forget the syntax a lot. We want to take a date time. And I think it takes function there. And we want this to be called date time builder. Okay, I stumbled my way through that syntax correctly. This here, what I have highlighted, is the type of thing. Like up here, this thing is a date time. This thing is a Boolean. This thing is a function that takes in a date time and returns a widget. That's what it is. By taking in a function instead of a widget, we can recreate the widget every time our time changes. So let's come down here to our build method. Instead of returning widget.child, we're going to invoke a function called dateTimeBuilder, and we're going to pass the current time. Then the implementation of dateTimeBuilder can configure its widget however it wants based on the current time. Let's go do that. This code here no longer compiles because child is no longer a property of time lapse. So let's cut this out. What we can provide is a date time builder. And what is a date time builder? It's a function that takes in a date time that we will call current time, and it returns a widget. So let's save that and see what happens. And just in case, let's do a hot restart. Okay, still nothing has changed. Why not? It's because even though we're returning this widget every time that we're asked, we're still based on the current time. That's not what we want. Let's get rid of now entirely. We want to base our widget on the current time that's given to us. Whatever time lapse is going to tell us what time it is, and we need to build ourselves accordingly. Time lapse gives us the current time, and we build ourselves accordingly. Now let's save. Notice that it says 11, 59, and 49 seconds. Why? Because that's exactly what we told it to tell us. We told it to tell us that's what time it was. And the reason time isn't changing is because we told it not to tick. What happens if we tell it to tick? Look at that. It's counting up, just like we want. This is how we handle the passage of time. We have a widget in this case whose sole responsibility it is to either report the real time or report a fake time, either frozen or actually changing over time, and to let us build whatever widget tree we want based on that time. That's the solution to the passage of time. And beginning in the next step, we're going to start to, we're already reacting a little bit with the clock here, but we're going to react with the rest of our scene to the time that we're given. Let's get our environment reacting to what we think the current time actually is. At the top of our tree, we have New Year's countdown screen. And as we've seen, inside of that widget, we have a scaffold, which holds a time lapse. Time lapse is our solution to the passage of time. And currently, we're just building a landscape. Now, we do want to change the landscape based on time, and we could do that right here in this builder. However, we're going to want to add more stuff in addition to the landscape. The landscape is just the first part. We're going to want a countdown. We're going to want a Happy New Year. We're going to want some fireworks. I don't want to shove all of that into this builder. And so I'm going to introduce another widget. I'm going to come down below time lapse, and I'm going to introduce a stateful widget called New Year's Countdown Page. Now that's very similar to New Year's Countdown Screen, right? Up here we have New Year's Countdown Screen, and now we have New Year's Countdown Page. What's the difference? The idea is that the screen really represents the entire screen. It takes over the screen, it does whatever it wants. The page is more like a piece of content. So we're going to tell the page exactly what time to be, and the page is going to render itself based on that exact time. The page is not going to worry about time lapse. I'm leaving the timing stuff to the higher level screen. The screen controls the time. The page just says, okay, how do you want me to render the content? That's the conceptual distinction. I'm going to take this landscape out of here. I'm going to cut that, and we're going to return the New Year's Countdown Page. It's going to have a property called current time. We haven't created that yet, but we will. And we're going to give it the current time. So let's go down to New Year's Countdown Page. Final date time, current time. We will generate the constructor for that. This is a required value. We need it to be provided. And for now, let's return exactly what we were returning before. I think we'll need to bring the time format down here because now we're formatting in a different place. So we'll come take this time format out of the top level widget, and we'll bring it down to the New Year's Countdown page. Also, we need to access the widget's current time instead of, we don't have direct access to that variable. We have to ask the widget. But with that, let's save. Everything looks the same. Let me do a hot restart just in case. Okay, everything's still fine. We're rendering the same thing. But now this New Year's Countdown page is taking over all rendering responsibilities for the content. We tell it exactly what time to be, but then it decides how to render. Let's begin with how to render this landscape. This mode should be based on the current time. Let's create a method which returns the environment mode, and we'll say build environment mode. And this is arbitrary how we break this down. I'm going to break it down the way I'm going to break it down. You can look at the hours however you want and make this decision. But if the current time hour is greater than or equal to 6 and it is less than 11 a.m., I'm going to return morning. If the current time hour is greater than or equal to 11 a.m. and, let's stop accessing this hour so many times. So again, if the hour is greater than 6 a.m. and it's less than 11 a.m., we're morning. If we're greater than 11 a.m., but we are less than 3 p.m., we are the afternoon. If we're greater than or equal to 3 p.m. and we are less than or equal to, 6 p.m., we're going to return evening. And otherwise, we are going to return night. Let's now replace the hard-coded mode with build environment mode. Let's save. Notice that immediately it went to nighttime. And why is that? It's because it believes that it's a little after midnight. And now let's test these different things. Again, why did we provide this parameter here? Is so that we can quickly jump to any time of day and any day of the year that we want. Instead of 11 p.m., let's jump down to 4 p.m. Now we're in evening time. Let's jump down to 1 p.m. Now we're in afternoon. Let's jump down to 8 a.m. Uh-oh. Got to be 08. 08. Got to have 2 digits. Now we're in the morning. So now time controls our scene, or at least our environment mode. Time controls our environment mode. We're one step closer to where we want to be. Starting in the next step, we're going to finally look at this New Year's countdown and celebration, which are also based on the chosen or current time value.